I'm Preetha Chatterjee. In this presentation, I will describe our work on automatic extraction of opinion-based Q&A from online developer chats. At the first place, why do we want to mine question and answers from developer chats? So one of the applications of mining question and answers could be towards building conversational artificial intelligence. So recent efforts in research in the field of software engineering is towards building virtual assistants that can help in specific software development tasks, such as pair programming, bug repair, etc. Now, as we all know that the early versions of virtual assistants, for example, Siri or Cortana, focused on short task-oriented dialogues, such as play a music, right? But then the more sophisticated versions deliver coherent and engaging interactions. And to do that, they often integrate specialized instances for one task. So for example, they could combine dialogue management, opinion mining, question answering to do one task. So in this work here, we focus on investigating two of these specialized instances, that is opinion mining and question answering. And this is done towards building an opinion providing virtual assistants for software engineers. So as a first step here, we extract opinion based question and answers from chats, and we call this system Chatio. And the corpus generated from Chatio could be used towards building this kind of virtual assistants. To design an automatic system, we actually formulated two subproblems. The first part focuses on automatically identifying the opinion asking questions, while the second part focuses on automatically extracting the answers to those questions. So now let's see an overview of Chatio. So how the intermediate modules connect to each other. So first we start with using a supervised machine learning algorithm for chat disentanglement. Basically, this is to extract out separate conversations from an interleaved chat history that is necessary for analysis. Now we move on to the opinion asking based question identification. So here we use a linguistic heuristic based technique to identify these questions. So let's see an example here. So this is the same question that we saw on the last slide. And here I show you the heuristics that we used to automatically identify this question. So basically all our heuristics are a combination of part of speech tags and a set of keywords. So I will move on to the next part of Chatio, which is the answer extraction part. So here at this point, we have already identified the question. Next, we consider each message or utterance in a conversation as a candidate answer. And we use the question and each of the utterances to make separate question and answer pairs. At the first step, we used a software engineering customized word embedding model, which has been trained on the recent Stack Overflow corpus and create joint Q&A embeddings. So these embeddings are then fed as an input to the convolutional neural network, where we learn about the semantics of the question and answer pair. And the output of the CNN is then fed as an input to a bidirectional LSTM, after which we finally make the answer prediction. We basically investigate two research questions. We divide it in two parts. The first part focuses on evaluating the automatic opinion asking question identification, while the next research question is on evaluating the answer extraction module. We used conversations from two different developer chat platforms called Slack and IRC, and we used 6 different types of programming communities. So the goal set, again, the human annotated data set for the question identification consists of 400 conversations across all these communities. And our answer extraction module is a little bit larger and consists of 2,000 conversations from these communities. So I'll start with talking about the first research question. So here we are evaluating the automatic opinion asking question identification. So we use 3 different types of sentiment analysis tools. The first one is SentiStrength SE, which is customized for software-related text. And then we also use 2 off-the-shelf sentiment analysis tools called Core NLP and NLTK. And then we also compare Chatio to another pattern-based technique called DECA. So this has been proposed to identify opinion asking questions in developer emails. So now I'll show you our the table which shows our evaluation results in terms of each of our evaluation measures for all the techniques that we saw. So from the figures here in the table, we observe that the sentiment analysis tools overall show high recall with low precision. And interestingly, for SentiStrength SE, actually the precision and recall is both low. We also see the other pattern-based technique called DECA shows a perfect precision of 1, and that is because it identified 1 true instance in the dataset, and therefore it has very high precision but a low recall. And finally, we observed that Chatio achieves overall better precision and F measure when compared to all the other techniques. Now, I will move on to the next research question. So here, this is about identifying, evaluating the answer extraction module of Chatio, and we compare it with 3 heuristic-based techniques, one machine learning-based technique and another deep learning-based technique. So I'll explain them one by one. So the first heuristic-based technique is location. So based on the intuition here that a question would be immediately answered, we take or extract the utterance next to a question as a potential answer. Next, to model the content similarity between a question and answer, we compare the average word embedding between them, and if it passes a certain threshold, we consider that utterance to be a possible answer. The next one is sentiment. So here the intuition is that the answers to opinion asking questions might exhibit sentiment, and therefore we extract any utterance exhibiting sentiment as a possible answer. Now, we combine all these heuristics as features and use a simple machine learning based algorithm as SVM to predict the answers. And finally, we also compare Chatio with another deep learning-based technique, which was designed to extract answers from a non-software related Q&A forum. So in this slide here, I show you the evaluation measures for each of the techniques that I discussed, and the measures are also shown for each of the programming communities that we investigated. So here, we first talk about the heuristic-based. So we see among the 3 heuristic-based techniques, location exhibits significantly better than the content or sentiment. And this is because content and sentiment often marks follow-up questions as false positives. Then we see that compared to the other techniques, Chatio achieves highest overall precision and recall. And another interesting observation here is that although Chatio performs consistently across all the communities, there is a drop in one of the communities, the orange one, for closure. And on a further manual analysis, we saw that in this community, answers are often provided as just code segments. There was no English text or not much text to it, and we couldn't model that semantic link, and therefore it was difficult to automatically extract those answers. In summary, Chatio automatically identifies opinion asking questions using a heuristic pattern-based technique and answers using a deep learning-based architecture. And this work could advance mining of information from developer chats towards building several applications, such as building specialized software engineering virtual assistants. The question and answer pairs that we extract from Chatio could also be used towards generating facts. It could be used for tool support for building recommendation systems, and the corpus could also be used toward understanding developer behavior and collaboration in sharing opinions.
Okay, so hello, my name is Francisco Servant. I'm going to be session chair for this Q&A today. And we have Preeta Chatterjee, who's going to answer your questions. I can see a question already in the chat. So the first question for you is, how many number of classes do you have here? Did you consider only 2 classes, positive and negative sentiment?
Correct, yes. So we didn't consider neutral cases. We only considered 2 classes, either positive or negative. So the intuition here was that opinions could bear any kind of clarity. It could be positive or negative. So we considered both of these 2 sentiment classes.
Okay, thank you. The next question is, how comprehensive are the heuristics for identifying questions? I'm curious if the model is basically a reflection of the heuristics, and if so, do you envision ways to improve it?
Absolutely, that's a great question. So we initially started this study by, we have been inspired with one of DiSorbo et al.'s paper on intention mining of developers in developer emails. And there they had this several categories for opinion asking, information seeking, etc. So what we essentially did, we started out with looking at the linguistic patterns that they used to detect opinion asking questions. So as a result, we found that those were not very efficient for chat conversations for several reasons. Because, for example, chat conversations are highly informal in nature, and the sentences are incomplete, and so on and so forth. So what we did was we used their heuristics and added some more linguistic heuristics to automatically identify the opinion asking questions. But if you go into the evaluation section of our paper, there we discuss briefly that some of the reasons or some of the cases where we could not correctly identify the opinion asking questions because of the shortcomings of using linguistic patterns. So for example, some cases, some questions did not follow recurrent linguistic patterns. And some questions were also like a 2-part question. So for example, would you suggest this question mark? And the second question starts with, or do you suggest using this? So these complicated structures were often difficult to detect by linguistic patterns. As a part of the future work, we are thinking about using machine learning techniques to automatically identify opinion asking questions instead of using only linguistic patterns.
Thank you. So let's see. Do we have other questions from the audience? Well, we get more questions. Let me ask you one that I wanted to ask you. So, when I think about opinions, right, in Q&A, there are many dimensions, right, over which to give an opinion. So maybe I have a very positive opinion about the user interface, but a very negative one about the stability of the application, or I have an opinion about the security of something, right? So do you see an opportunity for discovering these categories of opinions, and if so, do you think it will be useful to do so?
Sure. I think what you're referring to is like maybe aspect-oriented opinion mining. So maybe certain types of opinions that we might be interested in. So for this paper, what we did is that the data sets that we selected were mostly coming discussions between developers in programming communities. So all of the questions were really similar. They were asking about which API to use, what would be your opinion to using this API versus that, which library to use, and so forth. But that would definitely be interesting if we want to, as a part of the future work or possible extension, if we look at specific aspects and focus on opinions of specific types of things that we are looking for. So for example, Java libraries. So that is certainly a possibility. So for this paper, what we did was really, trying to understand that how many opinion asking questions were there. So in the beginning of the paper, we did a short empirical study. We were trying to understand that how prevalent opinion asking questions are. So for example, in Stack Overflow, you cannot ask questions which would ask for opinions. Opinions are certainly present in comments or answers, but asking questions about opinions are forbidden. So we thought, like, when we were looking at the data, we found that there are many questions which were asking for opinions, and these are certainly very useful for developers. So is there a way we could automatically mine that? So the first step was to first identify the opinion asking questions. But a bigger challenge was to automatically extract the answers to those questions, because chats are very informal, it's very noisy, and also the structure is different, right? Because you start with one question, then there could be a follow-up question. So there could be an answer to the follow-up question first before we see the actual answer. So we kind of also try to focus on or build a technique that would automatically extract both the question and answers, so that we can curate a question and answer data set consisting of opinion-based Q&As from chats.
Thank you. So let's see. I have another question that I wanted to ask you. I still encourage the audience to ask questions because I want to prioritize the audience questions. But because we have limited time, good, great. Have you considered how this would work for non-opinionated or fact-seeking questions?
So our paper consists of two parts, as I was explaining before. The first part focuses on identifying the opinion asking questions. So the linguistic patterns that we developed were definitely focused on opinion asking questions. So for example, if we are to look into fact asking questions, then the linguistic patterns would definitely change. But the answer extraction module that we used, it could be used for, it's very generalizable. It does not depend on any specific types of heuristics, and it could be, modified to use or to extract answers for any different kind of questions as well. So in conclusion, the first part, the linguistic patterns need to be changed depending on the type of questions that we want to extract. But the answer extraction module is generalizable and could be extended to other forms of answer extraction as well.
Thanks. So we have also a clarification question. Do you think sentiment analysis are the right baseline for detecting opinions? And why not compare with opinion mining tools like Opiner?
Sure. So there are a few reasons. So Opiner basically focuses on what Francisco was asking me a few minutes back about, like, aspect-based opinions. So since we did not focus on specific aspect opinion extraction in this paper, we kind of, used linguistic patterns to catch questions or to capture questions which were more broad. We did not focus on specific aspects. But sentiment analysis tools might not be the only tools that we want to use when we want to mine opinions, because there were some examples, there are some questions which might be asking for opinions. So as I was saying, that which path should I choose among these two options? Is this a better option to implement this code, or is the second option better? So these kind of questions often do not exhibit much sentiment, but some types of questions do, and that is why we used sentiment analysis tools to see, okay, can we, instead of using all these linguistic patterns, can we use the sentiment analysis tools to automatically extract the opinions from there?
Thank you. We're almost out of time, but I would encourage anybody with more questions to join the discussion room. You'll get a pop-up to join.